Hey guys, welcome to 75-day LeetCode coding challenge, and today we are going to solve our next problem statement: delete node in a binary search tree. So let's start. Given a root node reference of the binary search tree and then key, delete the node with the given key in the binary search tree. Return the root node reference of the binary search tree. Basically, the deletion can be divided into two stages. First, search for the node to remove. Second, if the node is found, delete the node. So we have given a binary search tree and the key, and we need to delete the node having value equal to key. So key is 3. So we need to delete the node having value 3. So we are deleting this node. So what we do to delete this node? We swap the fourth node with the position of 3 node and then delete the node. So this is the resulted binary tree, and as we can see, this is the valid binary search tree after the deletion of the node. So let's discuss the solution for this problem statement. So what is the possible cases of deleting the node from the binary search tree? So let's write it. Cases. So let's call the node to be deleted as a x. Let's call it x. So this is the node to be deleted. The first case is when our x node is a leaf. Node. So what is leaf node? It means there is no left or right child node associated to that node. So no right and left node exist. So first condition is x is a leaf node. Second condition is x has only one subchild. X has only one subtree, one sub-binary tree. So we can say right exist or left exist. So either a right binary tree exists or left binary tree exists. For first case, it is a leaf node, no right or left node exists. And what is the third possible case? Our x node has both left and right children. So this is the third case. So there are three possible cases. X is the leaf node. Second, X has only one subtree, either left or right subnode. Or third case is it have both left and the right subnode. So let's discuss all these cases. So first, let's discuss if it is a leaf node. So X is a leaf. So let's make one binary tree. Let's say 5 left node should be less than the root node. So let's call it 3. And the right node should be greater than our root node. Let's call it 7. And our x is equal to 7. So we need to delete this node 7, right? So for this, there is no right or left node exist. So the resultant node can be, so if we delete 7 directly, so the resultant binary tree will be 5 and 3 only. So basically, if the x is a leaf node, we do not need to do any operation. We simply can directly delete the node. We simply need to close this connection, and we can get the resultant binary tree. So for the leaf node, we do not need to do much. Let's discuss our second case when x has left or right. It have one of them. So let's say we have this binary tree 5. Left node should be less than our value of 5, 3. Right should be greater than our 5 value. So let's say 8. And let's make another one. And this is the right part, so 9 should be greater than 8. So this is also a valid subtree. And our node to be deleted is 8. We need to delete this node. So the resultant binary tree will be 5. What we can do, we need to delete it, and it have only one one, either a left part or a right part. So we can move this part here and we can delete this connection, and instead of it is pointing 5 is pointing to it can directly point to the 9, right? So the resultant binary tree will be this, right? So this is a valid binary search tree. So if we have, and let's take another case also. So similar thing we can do for the it have the only the right part. Let's say another case where it have the left part, right? So we do the same process again, right? It is the same process. So if x has a left or right, what we are doing, we are replacing the next node with our value of x. So we move it here and 8 goes here, and then 8 is a leaf node. Then we can, then it lies on the first step only. If we make it a leaf node, then we can delete it directly. So for this case, we simply swap 9 with 8 and 8 with 9. Then we can delete it directly. Right. So our second case is covered. Now let's discuss the third case where x has both left and right. So let's now again write it. So 5, 3, let's call it 8, 7 and 9, and you can say 2 and 4, and our x value is 5. So we need to delete the head node itself. We need to delete this node. So if we delete this node, which node we need to swap with the value of 5? So we need to discuss this part. So what we can do, we can swap x with next in order successor. So if x has both left and right, we are swapping the x with the next in order successor. So let me come to it. What is in order successor? So first you need to learn about what is the in order traversal mean. So let's do the in order traversal for this this tree. The in order traversal is, first you go to left, then you go to root, and then you go to right, right? So let's write in order traversal for this tree. So in order traversal for this tree will be, we start from the left. So we start from the fifth position, but we move to the left. So first we start from the fifth position, then we move to the left, then we again move to the left. So first we print 2, then we print root. So 2 have the root 3. Then we print right. So right is 4. Right. Then we again, so first we move to the left, then we printed root, then we printed right. So this left part is covered. Now we print the root again. Then we move to the right, but we then move to the left again. So move to the right, then we move to the left again. So we print 7. Then we print the root 8. Then we print the 9. So this is the in order traversal for this binary tree. And what we have to do, swap x with the next in order successor. So our value of x is 5. This is here, x equal to 5, and we need to replace it with the next in order traversal. This one, 7. If we replace it, then the new binary tree will be 2, 3, 4, 7. In place of 5, we place 7, and then 5 and 8 and 9. So this is our new in order traversal binary tree. And now let me draw the binary tree also. So we move the 7th position to 5th position, and 5th position to 7th position. So we move it here, 7, 3, 2, 4, 8, 5 and 9, right? and now it 5 comes as a leaf node. It is a leaf node, then we can directly deallocate the space. Basically we can just point the left part of this node equal to null, so we can deallocate it directly. This is our first case only, when x is a leaf node. So we can delete it directly, and the resultant node will be 7, 3, 2, 4, 8 and 9. So this binary tree, if we delete 5, it comes as this binary tree, and this is the valid binary such tree. So if x has both left and right, we swap x with the next in order successor. So I hope you got the all the three cases. Now let's jump to the coding part and implement all three cases. First case is if so in binary search tree, left node should be less than our root node, and the right node should be greater than our root node. So if our key is less than our root value, we know that it exists in the left subtree part. So let's say root dot left equal to, call your delete node method again, doing the recursion part. Let's do recursion now. Delete node. So we know it exists in the left part of the binary tree. So root dot left comma key. And else, if the next case is if our key is greater than our dot value, we know the root exists in our right subtree part. So root dot right equal to delete node. So two cases is covered. The last case will be if our key value is equal to our current node. So this is the case when we got we got the node with the value of key. So let's write the first case. Our x node is a leaf node, right? This is the first case. So we deallocate the connection directly. So 5 pointing to 7. So we break this connection. Now 5 point to the null. So if x is a leaf node, then if and how do we check it if it is a leaf node? So its left and the right subtree part should be null. So right root dot left is equal to null, and root dot right part is equal to null. We know it is a leaf node, so here we simply return null, right? Because here we are allocating the node to the left and the right subtree part, and we are doing the recursion. So if we are getting current node as a leaf node, we return null. So it means the connection is got break because we have returned the null during the recursion process. The first case is covered. Now let's discuss the second part. X has left or right subtree. This is a second case, right? So we need to handle both cases. If the x has the right subtree, and another case is that x has the left subtree. So what we can do, if from 5 by recursion we are going to the 8, we can directly return the connection to the 9. If I can return this connection directly to 5, it will make a, so suppose 5, let me write it again. So 5 pointing to 8, then 8 is pointing to 9, we are doing recursion. So when if we do like this, so we have written root dot right equal to recursion, right? We are calling the recursion method. So instead of giving the link of this, we can return this link directly in the recursion. So now 5 will point to the 9 directly, and this 8 will be gone. So if x has a left or right subtree, so one case is x has left subtree. Now how we can check it? If root dot right is equal to null, or we can say root dot left is not equal to null. I think we should write root dot right is equal to null. So if the right subtree part is equal to null, we know it have the left subtree, right? And another case is if root dot left part is equal to null. So it means it have the right subtree part. Let me write it here. X has right subtree. Okay, so we need to handle both cases. So if the x has only the left subtree, we can return root dot left pointer, right? And if it have only the right subtree, then we return root dot right. Right, and we are doing the recursion because we are allocating root dot left, root dot right to the next value. So here, if our right part is equal to null, we directly return the left only. So if 5 is pointing to 8 and 8 is pointing to 9, after this 5 will directly point to 9 only. So these both cases are also handled. Now the third case we need to handle is x has both left and right subtree. So what we are doing, if x has both the left and the right subtree, we find the next in order successor and swipe it with the value. So let's write a method to find the next in order successor. Public static in order successor. It's very easy to find the in order successor. Let me explain it. For this binary tree, 7, 8, 9 and 10, 6. So this is the binary tree, and we need to find the in order successor for this. So what you can do, you can first go right and then you move to the left direction only. So for this, the in order successor is 9. Even if I extend it like this, ignore the duplicate value, I'm just explaining the concept. So you can do something like this. So find the in order successor again. You first go right side, then you move to the left side only. So you move to the left side, then again to the left side, then again to the left side. So now the in order successor is 12. So first you move to the right side and then you move to the left side till you find leaf node. This is the way to find the next in order successor. So let's write a code for this. So suppose we have getting a node, we can define a temp variable assigning the value of root while our we are moving to the left direction only, right? So while our temp dot left is not equal to null, move to the left direction. So temp equal to temp dot left. We are only moving to the left direction, and at last return your node temp. We can find in order successor easily. What? So let's find the in order successor. Else if it so tree node in order successor equal to in order successor. Remember, first we move to the right direction, then we move to the left direction only till we get the leaf node. So pass your root dot right direction. Now we get the in order successor. What we are going to do? One thing we can do, if we find our in order successor, we can update this value. So suppose our key is 7, so we can update our in order successor with the value of root. So our key came as in 7. We find the in order successor. We can replace the value of 7 with 12. So here instead of 7 we can write 12, right? And we can update our key to be 12. So now in the processing during the recursion, we updated the value of key. Now it will delete the leaf node directly. So instead of swapping only, we just replace the in order successor with the value of our uh, key node, and then we update the value of key. So now here also 12, here also 12, but this during the recursion this goes as a leaf node, so it will get deleted. So now let's do this part. So in order we found the in order successor. Now we assign the value of in order successor value to our root node. Then we update the value of key with the in order successor value, and then we again call the our delete node. So we are moved to the right direction, and we know that our key goes on to the right direction only, right? Because we updated the key value, and in order successor exists in the right side of the binary tree. So we can move to the right side of the binary tree now. Root dot right equal to call your tree node. Sorry, call your delete node method again. Pass your root, comma the value of key. Sorry, root dot right. We already processed the current node, so we move to the right direction, and we updated our value of the key with our in order successor value, right? So this third part is also done. Now at last we can return the our root node. So the coding part is done. Now let's run the test case if our solution is working or not. So we got the compile time error. Let's make it shorter to understand it. So in order successor, let's call it this one only. Now it is easy. Okay, so we are getting a runtime error because parameter one is null. Let's check. Yeah, one condition we also need to check if doing recursion, if we reach to the leaf node, if our doing recursion, we reach to the end of the node, we should return null. You have root in the return null. This additional condition we need also need to add. So yeah, our test case is working. Now let's submit the solution part. Yeah, so our solution is also working. And thanks for joining the session. Let's meet tomorrow.